Maritime Academy. Local winds. Local wind systems. Thermal circulations. Initially, there is no variation in pressure or temp, therefore no wind. When the north is cooled and the south is warmed, a pressure gradient, more dense and less dense air, is created. At the surface, the air pressure changes as the air aloft begins to move. As the air aloft moves from south to north, air leaves the southern area and piles up above the northern area. Shallow, 1 kilometer, circulation brought on by temp changes is known as a thermal circulation. Local wind systems. Sea breeze. A type of thermal circulation caused by uneven heating rates of land and water. Land heats more quickly during day than the adjacent water. The intensive heating of the air above produces a shallow thermal low. The air over the water remains relatively cooler than the land, and a shallow thermal high develops above the water. Overall effect of this pressure distribution is a sea breeze that blows from the sea toward the land. Local wind systems. Land breeze. At night, the land cools more quickly than the water. With higher surface pressures now over land, the wind reverses itself and becomes a land breeze. Land breezes are typically weaker than sea breezes due to a weaker temp contrast. Local wind systems. Monsoon. The word monsoon comes from the Arabic mawsim, which means seasons. A monsoon wind system is one that changes direction seasonally. One direction in summer, another in winter. This seasonal reversal of winds is well developed in Eastern and Southern Asia, similar to a large-scale sea breeze. Local wind systems. Northeast, monsoon. In northern winter, the continental air becomes colder than the ocean air. Large high pressure develops over the cold land, centered over Siberia, with a pressure about 1036 MB. The equatorial low of 1012 MB being oceanic and remains practically unaffected by the change of season. Sinking air diverges from the high, which is responsible for the fair weather. The monsoon force is about 3 to 4, with heavy rainfall over east coast of India. In China, CPG is larger. Wind force 5 to 7. Dry season is between December and February than the ocean air. Local wind systems. Southeast monsoon. In northern summer, air over the continents becomes much warmer than the air over water. A shallow thermal low develops over the continent, centered over NW India, with a pressure of about 994 MB, which is considerably lower than the equatorial low of 1012 MB. A PG develops from the equator towards the northwest India. Air rises at the center of the low, initiates convergence. Southeast trade winds blowing from oceanic high at 30 degrees S towards the equatorial low crosses over the equator and blow as southeast wind, force 7 to 8, towards the low over northwest India. This causes moist winds from the ocean to blow inland. Hills and mountains provide additional lift. Rainy season is from June to September. Katabatic wind. When the Earth's surface cools by night, the air next to the surface is also cooled and its density is increased. If this cold air is on high ground, there is a tendency for it to sink down to lower ground. If the high ground is on seaside, the downflowing cold air will move horizontally when it reaches sea level, which may reach force 6 to 7, e.g. coast of Greenland and Adriatic regions. Adiabatic wind. This wind is less noticeable as it blows up the sides of valleys with considerably less force than the katabatic wind. The air at the bottom of the valley is warmed by conduction from the heated land during the day, and this air, being less dense than the air above it, flows to the top of the valley by following the warm sides. Local wind systems, mountain and valley breezes. Similar to sea and land breezes. During the day, sunlight warms valley walls, which warm the air in contact with them. The heated air rises and forms the valley breeze. During the night, the slopes cool quickly, chilling the air in contact with them. The cool air sinks and forms mountain breeze. Local wind systems, Chinook winds. This is felt on lee side of high ground and results in temperatures on the lee side being higher than those on the weather side if the air passing over the high ground has been cooled to below its dew point. As the air rises on weather side, it cools to its dew point, and as precipitation occurs, the absolute humidity decreases. Due to decrease in absolute humidity, the dew point temperature on the lee side will be considerably lower than that on the weather side, which means that the condensation level will be higher on the lee side. Below the condensation level, the air will change its temperature at the dollar, whilst above it, it will change its T at solar, as the condensation level on the lee side is higher than. On the weather side, it follows that the descending air will warm at a greater rate than the ascending air cools. This results in higher T on the lee side. Tornado and waterspout. A tornado is a violent whirlwind of the cyclonic type. Its axis is nearly vertical, extending from the cloud base downwards and often reaching ground level. Conditions most favorable for their formation are when MP air from NWLY direction overruns MT air from the Gulf of Mexico, leading to a steep lapse rate and great instability and formation of tornado some distance ahead of the surface cold front. Its internal pressure may be less than 20% of external air. Its width is 50-500 meter, with wind of often hurricane force, up to 400 km/h. Generally travel at speed of 10 to 30 kts from east to west, and may last from a few minutes to a few days, covering a track of a few hundred meters to a few hundred miles. Tornado cause an intense upward current at the center capable of lifting heavy objects. If develop over desert, then it called dust devil. Tornadoes are associated with isolated CB clouds. The formation requires great instability, high humidity, and convergence at low level. Similar conditions for formation of thunderstorm. Areas of occurrence, mostly US continent and West Africa area. When passes over sea, large quantities of water are carried up by the vertical current of air at the center, forming a water spout, which appears as a thin funnel-shaped, opaque column, broad at the top and very thin at the sea level. Bora is a katabatic wind that blows over the north and east coast of the Adriatic Sea from a direction between N and E. It can attain gale force in a very short time without the usual warning indicated by barometric pressure. It can be a danger to ships at anchor. Regale, a strong northeast winds found in the central and western Mediterranean Sea, which is important for ships in Port of Malta and east coast of Sicily, where the ports are open to no winds. It occurs mainly in the winter and after passage of a depression. Levanter, a light to moderate east wind in the Strait of Gibraltar, accompanied with excessive moisture, cloud, haze, or fog, and sometimes rain. When blowing moderately or strongly, the Levant causes heavy swells on the Mediterranean. Usually gentle and damp, the Levant frequently brings clouds and rain. Kempson, a southerly wind which blows in Egypt and in the Red Sea ahead of eastward moving depressions. It is liable to be strong, and as it blows from African interior, it is hot, dry, and often dusty. It occurs from February-June and is most frequent in March and April. Shamal is any northwest wind in the Persian or Oman Gulfs. It is a warm, dusty, dry wind from the desert of Arabia. It may change direction and blow from west or southwest. No indication is given by barometric P of the approaching of a shamal, though the wind force at winter can reach force 8 to 9, sometimes with rain squalls, thunder, and lightning. It is more continuous in summer than winter and is most frequent in North Persian Gulf. Occurrence of heavy northwest swell, especially in south of Persian Gulf. Maritime Academy. Local winds.